Okay, so before we go forward, congratulate yourself because this has been a very difficult playlist and we got through the hardest part. Doing Firestore and authentication is, I think, the most important, but also the hardest part by far of any of the Firebase products. And so now we're going to start jumping into a bunch of other products, which hopefully you guys can relax a little bit as we get into. Maybe not this one, but definitely the next couple. For those of you who are just joining, my name is Nick. This is Swiftful Thinking, where we cover all things Swift and Swift UI related. This playlist is a Firebase Bootcamp, so we are learning everything we need to know about how to use Google Firebase in our iOS projects. And in this video specifically, we're going to learn probably everybody's least favorite feature, which is security rules. So when I say least favorite, because it's just kind of annoying and boring to have to write these. But as you guys are going to see, and as I'm going to explain in the video, we do these for our own benefits. Security rules are like an extra layer on top of your database that can help protect it from basically unauthorized access to your data. So depending on how you write your rules, you can use these in different ways. So for example, maybe you have like posts or data in your database that you want to ensure that only authenticated users can see. So we can write a rule that says, if the user is authenticated, allow them to read from that collection or something like that. Or maybe we wanted to make it so that only the current user can edit and write to their own profile. So that might sound a little counterintuitive, right? Because we can write code to make sure that a user only edits their own profile. But imagine a situation where you wrote the code wrong, put it into production, and then one user is editing someone else's profile. That would cause chaos in our application. Instead, we can write security rules to help us sleep at night that basically say, double check that the user is the same user who is editing their own profile. And while that hopefully will never actually trigger, it is nice to have that extra safety check on our database. In this video, we're going to start with a bunch of really simple rules, and then we're going to jump into some more complex rules, like adding admin access to your application, to your database. Unfortunately, we cannot write these rules in Swift, but the syntax to write these is actually very similar to what we do in Swift, so I'm pretty confident you guys will still be able to figure it out.
All right, welcome back everybody. My name is Nick. This is Swiftful Thinking, and I am super excited because we finished all of our Firestore code. In the last probably 5 videos now, we covered, I think, everything you need to know about how to use the Firestore database, and probably more than you needed to know. We covered pretty much all of the core functionality that it has. The last thing that we need to touch on, though, before we totally move away from Firestore is actually the security rules. And so if we're in our Firebase console here, there's actually a tab here called Rules. And so basically what it is on top of the database, we can add rules that will either allow or not allow certain people to read or write from certain places in our database. So talking very high level here about some examples. Right now, anyone who basically has a link who has access to our database can read or write from any file in our database. And if I'm just developing my MVP, that's okay, right? If it's just me and my friend, I'm not really worried about, getting hacked or a bad user or writing some bad code that's going to negatively affect the whole app. But we can imagine, for example, maybe we release the app, we get thousands of users on our app, and then all of a sudden we write some function wrong for editing the user profile. And in the situation, we accidentally use the wrong user ID when we were editing a profile. And then you release that app to the public, and all of a sudden one user is trying to edit their profile and it's actually updating another user's profile. Well, in that case, that would be pretty detrimental to our entire app, right? That would be really kind of scary as a user and as a developer. And so this is like a prime example, right? In your app, the user that is going to be editing a user profile. So right here, I have my user collection, my user document. This user document is probably only ever going to get edited or updated by this user themselves, or maybe by an admin. But we would, at least in this app, we never want another user to edit this user's profile. And so for that reason, I can actually add a security rule that says only allow this user to edit their own profile. And so that would save me if I ever wrote like the wrong code, right? And one user goes to edit another user's profile. When that request actually reaches out to Firebase, Firebase is going to check if it is the correct user. And if it's not going to let them do that action. And so at a high level, that's kind of what security rules do. Another big one is, especially if we're using authentication, most of the time, we really only want authenticated users to have access to our content. So this allows us to ensure that everyone that's using our platform is authenticated. They are who they say they are, right? So for example, if some hacker got basically a link to our database and we had no rules, they would be able to read, they would be able to write everything in our database. But if we had a rule that said only authenticated users could read and write to our database, well, then only the users who have gone through our authentication process would have that access. A final pretty common use case of these rules is if you have some sort of maybe like content that is managed by your team or internally. So for example, I have products in my database, but you could imagine like Spotify, right, has all of the music in their database, all of the audio songs and files. Well, there's never a situation in the Spotify app where a user like you or me is actually going to edit the song and the album and the data that is actually being played in their player, right? And so they probably have a security rule that says only allow our content team and our admin to update the song data and don't allow the public users to update the song data. So cases like that is why we add these rules, and really they're for us as the developer to sleep peacefully at night. Because once you have these rules set up, you know that even if you write some bad code or someone gets access to the database and tries to do something weird, you have these rules in place and they're going to catch all those errors before actually messing up your database. So that's enough of me talking. Let's go in and write some rules. And so there is documentation on this as well. If we go to the Cloud Firestore and we go to secure and validate data, and we come down to the structure security rules, there's a whole section on this. And unfortunately for us as Swift developers, we actually can't write these rules in Swift, but the code and the syntax is actually relatively simple, and I think you guys will be able to catch on pretty quickly. This is the basic syntax of what we need to do. It's essentially pointing to your database, and then you match the collection and the document that you're trying to refer to, and then you give it a rule for who are we going to allow to read this document, and you put a condition. If the user is authenticated, let them read. And we can do the same thing for write. And we're going to go through a bunch of use cases now, but I definitely recommend checking out this documentation. There's a lot of good stuff on here, especially some more intricate rules that maybe we're not going to implement. But for now, let's just jump back to our database. Let's go to the security rules and let's look at what's here. So if you were with me when we started and we set up our Cloud Firestore database at the very beginning, before we actually created the database, it asked us, do we want to use the production or test rules? And we clicked the test rules. And this is actually the test rule that it gave us. And so this set of rules right now is saying, go to any documents in the database, go to any documents, and then allow everyone to read and write if the request.time, request being the actual time that the device or the app is sending the request to Firebase, is less than this date. And this date is February 20th, 2023. This is about a month, I think, after we set up our database. So it's saying right now, just let anyone read or write as long as the current time is less than this date. And so if we were to change this date to some date in the past, today is January 2023. If I change this to 1 and then I were to publish this, immediately, as soon as I publish this, nobody would be able to read or write to anywhere in our database. So this is important because these rules are publishing to production as soon as we click this publish. And right now, it's not a big deal because we don't really have users. But you could imagine if you have a production app and you're publishing rules and you accidentally write one wrong, well, then it's literally going to like cut all of those requests off immediately. More often than not, my recommendation would be to set up your rules before you push to production the first time. So if I am developing and I add a new collection to my database, I am probably going to try to write those rules before that feature actually goes to production. Anyway, all right. But before we actually do that, let's just get our app running right now. So right now, I'm just going to build and run the app that we have. So if you guys are with me, we have a little app that has like products and a user on it. And hopefully it still works. Cool. And it looks like we still have our products. We still have our user profile. I'm going to go ahead and change this to January. So it's a date in the past of where I am at right now. And I'm going to do the same thing. I'm going to build and run our app one more time. Let's check out the simulator real quick. And you're going to notice that nothing is now loading. Literally, because we wrote this rule, everything is broken in our application right now. And if I look at the actual console, we can see listen for the query has failed because we have missing or insufficient permissions. So if you ever see this warning in the console, it means that you're trying to basically read or write to some location in the database and a security rule is blocking you. And we can see, so the listen for query is at the products collection. And then here we're doing another one at the user, and this user ID has also failed. And that's because our security rule right now says basically no one can read and write to the database because it is after this date. All right, let's go in and actually start writing some custom rules now. And so we're going to kind of use the same format, although we're going to look real quickly at the documentation for these limits. So I'm going to go to the Cloud Firestore, secure and validate data, write conditions, structure security rules. And they have a little sample here for they are matching the city's collection, and this is the document ID inside that city, inside the city's collection. So I'm going to copy that and just use that same syntax that they gave us. So I'm going to come up here. I'm going to delete this. I'm going to paste my new one. And so we obviously don't have cities in our app, but we do have users. So let's write one for the users first. So I'm going to come up here and I'm going to say users. And then this is going to be the user ID. Now, when we set up our database, right, we actually made the user ID the document ID here. And so this, within these curly brackets here, is actually referring to the document ID, which happens to be the user ID in this case. Now, who do we want to allow to read from the user? Well, I'm just going to say if true. So I'm just going to allow anyone to read and write from the users for a second. And same thing for write. All right, let's publish these and just make sure that it works. So I'm going to, let's run the app one more time. See if we get our printouts here. And so the products are not loading, but the user profile is loading, which is great. And so that's a good thing to point out here. So now that we got rid of our original rules, remember our original rule said any document can read and write. Now we only have a rule for the user's collection. And in this situation, we're looking at the products collection. And so what this tells us is that anything that is not written in our rules is automatically not going to allow any read or write. So right now, this whole products collection is not accessible in our app because there's no rule for it at all. But of course, we will get there and we will write some rules in a second. So who do we want to allow to read from our users? Well, we're going to allow, in most apps, I think users can also read from other user profiles. Maybe not in the current app that we're building, but a lot of apps you can see another user profile, right? You can see another image, you can see another user's name. And so most of the time you probably just want anyone to read other users. But if we're using authentication, we probably only want to allow users that are actually authenticated to have that access. So right now in our app, we are authenticated. We have our authenticated ID here. So let's write a security rule. If the request, again, the request is literally the request coming from the device to the server. if that request.auth, so the authentication within the request, that's coming from the Firebase SDK on our app. And we're going to say is not equal to null. Null is basically the same thing as nil in Swift. So if the auth is not null, meaning they do have an auth, then we'll let them read. And we're actually going to do the same thing for the write down here in 1 second, but let's just publish this for now. Let's get it going. And let's run our app again. I just want to make sure that we can actually still read, even though we wrote this rule in here. Awesome. And just to prove that this is working, if we went and changed this and said, only allow them to read if they're not authenticated, so it's equal to null, and I go and let's restart our app again. Well, now I am authenticated, and so I'm failing the rule. So these rules literally work in real time. Let's put that back, and let's write some more complex rules. Another really cool thing we can do is, so for writing, for example, you might only want to allow the current user to write to their own profile, right? And I think that's probably a very common use case in users. Very, very rarely are you going to edit another user's profile. And so we can write our rules. We can write one that says if the request.auth.uid, so the UID from that auth. And remember, if we were back in our project and we look at when we have the auth manager, when we have these functions from the auth manager, we made this auth data model result, which we're passing around our app. And that includes a UID, an email. And this UID that we've been passing around our app is quite literally the same UID that's coming from the auth right here. So we're saying if that user ID is equal to the user ID of the document, so the document ID, then we'll allow them to write. So only if your authenticated ID is equal to that document ID can you write. And so we can publish it now. Let's restart our app. Cool. And I should be able to do all this. Awesome. And this is, I'm reading and writing again from my own user ID. Now, if I were to come into the app, and let's just say actually, for example, where are these functions? We have a profile view model. Cool. Right, we could pretend like maybe we have, I don't know, some developer on our team who is just starting out. They don't really know what they're doing, and they wrote some code that said, where's the user's premium, maybe? Toggle premium status. So when we go to toggle premium status, we pass in a user ID to the premium status, right? We're passing the user ID and we're changing their status. What if maybe we have some, developer on our team who accidentally writes this wrong? And maybe he adds in a random user ID or some other user's user ID, right? And then we were to release that and we didn't know that there was a bug there. Well, thankfully, now that we have this rule, it's going to check if the user ID that we are trying to write is matching our authenticated user ID. And so if I look at the database, if we didn't have this rule in place, right now, this function would create another document at the user ABC and then toggle their premium value. But of course, we wrote our security rules, and when we click this, nothing happens. And we can probably get that printout here right at users ABC failed because we don't have missing permissions. So this is literally the perfect use case for, it takes us a little extra time to write these rules, but it does save us in the long run. And it saves us from issues sort of like this. So cool, we have our rule set up now so that only the current user can edit their own profile. And the syntax of these rules is actually very similar to Swift. We can also say if the user is not authenticated and they are the current user. So we can do something where we can literally just copy and paste this and put a double ampersand for and. So this is request So this is literally the same logic that we write in Swift. We can publish this and it should be working. I'm not going to test it. I know it works. We also can be even more specific in our rules. Not that we really want to in this case, but let's just go through some examples. So I'm going to comment this out quickly and let's write another write rule. And let's say allow write if the resource dot data dot. Now, when we access the resource, that resource is referring to the document at this location. So if users/user ID and my user ID is FLQ, that's referring to the FLQ document, literally this document right here. And so since this security rule is actually on the server, it's on the database, we can actually access the data inside this document as we're trying to read or write to it. So for example, this user right now, user is premium is false. And so if I were to come here and say, if the resource.data dot, and let's get it exactly, user underscore is premium, just copy that and come in here. So I can say if the resource, the data at the document, user is premium, if that value is equal to false, then we're going to allow people to read and write. And so I will publish this. Let's just try it out quickly. I'm going to open up Xcode, run my project one more time, and let's try to read and write. And we know that right now the value is false, so it should work, right? Let's come into here. Very, very cool stuff, guys. And I'm going to go to my user profile, and of course it is false. So hopefully I can toggle this and it will work. Looks like it's true. But now we know that rule should break because user is now true. So if I try to toggle it back, we're stuck because we don't have permission to change that. So this is not a good use case for a rule like this, but there are use cases where you do something like this. So maybe only premium users can access certain content in your app. Well, we could write an extra security rule saying only allow this user to read this if they are actually premium. And we can write the rule like this, and we can write the rule like this. So this was one example of actually looking at the data at the location of where we're trying to read and write. Okay, I'm going to come back in here and let's change out that rule because obviously we don't really want to do that. I'm going to leave it here just so that you guys have reference to it. Let's write another rule. We're going to say allow write if, and this time we're going to say if the request dot resource dot data. All right, so the request, remember, is the request coming from the device to the server. And the resource we had here is the resource where we're trying to write to, the document. But now we're doing request dot resource. Request meaning the request coming from the device, and the resource meaning the document that we are sending from the device. So when we are actually making these calls, right, I have my update premium status here. We are including the premium value and is premium. And so this dictionary is actually the data that I'm sending in the request. And that's the data that we're accessing here. And so what we could do is have some sort of secret key or something in our app where we maybe when we write this, we include like a custom key. I'll just put this for example, and we make the custom key a 1, 2, 3. Why not? Right? And so now we can write a rule that says only allow the write if that data dot custom key is equal to 1, 2, 3. All right, so this is a little different now, right? Because this was the data at the location that we're trying to write to. This is now the data that we're sending to the location from the device. So if the resource contains the custom key, allow read and write. Let's publish that and let's check it out. If I think I have to rerun my app from Xcode real quick. We'll go back to that user profile that we're trying to edit. And so I can read and write perfectly, and we can see that the custom key actually pushed because that's what we were sending in the payload. And so now we have the ability to read and write because we have that custom key. Now, obviously, this custom key is kind of not a clear use case, but I wanted to show you guys that we can actually incorporate the data that is being sent as well. And so sometimes you might want to do a validation on that to maybe make sure that it's like the right data or something like that. And we can prove this though, if we change the security rule to maybe it has to be 1, 2, 3, 4, which it is not in our app right now. As soon as we start doing this and we look at our database and we look at we no longer can read and write to the database. So it literally is that instantaneous, the rule goes into effect. All right, I think we have like 1 or 2 more to test out here. I'm going to comment this out. I'm going to go back into our Xcode and also comment or delete this because we don't really want that. And a common version of, I think this one that I want to show you guys is sometimes writing one generic rule across the board doesn't really work, right? So if you could say, if the user is premium, that works, if that works for every single user. But sometimes some users or maybe it's not users, maybe it's some documents, basically, you want to allow users to read and write, but maybe it's like custom on your end that only specific documents are available at certain times, right? Like maybe you have documents that are not active in your app. And so you could do something like where in your database, and let's just use the user profile for now, that you have a field like visibility. And maybe this is either private or public. And you could then write security rules around that and have like your content team or your internal team updating these values. So like right now it's public and we can write a security rule that says allow write if the resource data dot visibility is equal to public. And this would allow us to basically have this custom rule that we can change at any time, right? We can change this, if we wanted to hide something all of a sudden from the database, we can write it as private and all the functions, all the fetches will fail. And so if we publish this, I think it will work right now. Yeah, it looks like it's working. But if I change the visibility to private and then keep going, it's all of a sudden not working. So that's just one way to handle it. And we can actually even write these if statements. If they start to get a little more complex, we can convert them into functions. So I'm going to do this right now, and I'm going to do it outside of these brackets here. So I'm going to put it right here. So I'm going to put it down here. I'm going to still do it within the match of the documents though. So it's still within this database. I'm going to create a function rather. So the syntax is very similar to Swift again, and we're going to write literally if is public. It's a function, open brackets, and we're going to return in here, return if the resource data visibility is public. And I think we need this semicolon here. And so now we can, is that not working? Oh, it's giving us a warning just because we haven't used it yet. Oh, that's interesting. All right, so now what we can do is say if is public and put the semicolon there. All right, same thing, the same rule, but we kind of just cleaned up this line of code a little bit and it is not working. But if I turn my visibility back to public, we are good to go. Sweet. Let's keep moving here. Let's move to the products now because obviously the products are not working in our app. So we're going to have to write another match statement for the other collection, right? This is the users. Now we're going to go to the products. And so in here, let's write match. I'm just going to use the same syntax as this line. Product. And this will be the product ID. Close the brackets. And then open another set of brackets. And we're going to allow, let's do allow read, write. So both read and write if request.auth is not equal to null, sorry. So anyone who is authenticated can read and write to the products. this should now work if I restart the app and we wrote our rules right. We can now get our data back here. All right, let's go through some more unique stuff here. So far, we've only done read and write. There's actually a couple other keywords that we can use here as well. So feel free to go to the Firebase docs and read through all of these pages here. It's honestly great content if you really want to dive into these rules more than this video. But some examples of other things that we can write is get, list, create, update, and delete. All right, and so we're just going to write a couple comments here, just so that we have them in our file. So I'm going to say, normally we can read and write. And so when we write read, that means any type of reading is allowed, okay? But we could be more specific than just say any reading, and we can say get. And get, Firebase is telling us, is applying to single document reads. So that's what get is. So if I'm fetching a specific document at this user ID, and I'm pointing to one specific user ID, then then a get rule would manage that. Alternatively, I can have a list. And Firebase here is telling us the list applies to the queries and collection read requests. So any of those queries where we were sorting and filtering, those would be list requests. And these are all actually lowercase, so I'm going to put this as lowercase. List. All right. And so when we use read, it includes both of these, but we could separately also only allow one of these or write different rules for each of these. So if we include read, then we don't need to include both of these. But if we're including both of these, then we probably don't need to include a read rule. And then write works the same way as this, except the children of write are create, update, and delete. And those I think are pretty self-explanatory. So we have create, we have update, and we have delete. And those are self-explanatory. Create is creating a document. So if the document is not there and you're adding a new document, like when we set data for the first time, that's create, add document. Update is an existing document that you're basically trying to edit the existing document, and then delete is to delete the document. So delete's probably a pretty important one, right? Because in your app, maybe only the current user can delete their own profile, but most of the stuff in your database, you probably don't want to allow to be deleted, or maybe only from admin or something like that, right? If we were Spotify and we had songs in our database, there's probably not a use case where songs are just getting deleted on a whim. Maybe they have some CMS where there's some admin who can delete songs, but our average user should probably never be allowed to delete any of that content, right? Because that's the CMS content. All right. And I'm not going to go through all of these examples because I think they're pretty self-explanatory, but the syntax would look just like the same as read and write. It would just be like allow create if, and we can put in whatever logic that we want, right? So if we did this and we only had that as a rule, it would be users can create documents, but right now they're not allowed to do anything else. They can't edit it. They can't delete it. They can't read from it. All right. So in our app, who can create a product? Well, we only really want the admin of our app, our internal team, to be creating products. We have no use case in our app where a user is adding a product to this app. And so what we want to do is probably allow create only if the requested user is an admin. So right now, obviously we don't really have like an admin set up, but I'm going to pretend like my user ID is the admin. So if you had a team of like 3 or 4 people and they wanted to have access, you could go in and get their user IDs and only allow their devices to make these up. So just because our app right now is reading, I'm just going to write a read rule. Let's comment this out. Let's say allow read if the request.auth is not equal to null. So the user is authenticated, and maybe the request.auth user.uid, the authenticated user ID, is equal to an admin ID. Put in the close parentheses here. All right, so I'm going to publish it. Let's try to do another read here. And it looks like it still works, right? But maybe we had a different admin ID. I'm going to copy this, publish this, right? So now I'm a user, I'm using the app, and I can't read anymore because I'm not an admin, right? So we can restrict rules to specific users like this if we want to. Now, of course, if we had a bunch of admin in our app, this is not a very scalable approach because I would have to basically copy and paste this and say, and if they are this admin ID, or so we can copy this, right? And then paste another one. So we can say if they are this UID or this UID. But obviously, if we have 50 user IDs, this is not a very scalable approach, right? So that's really not what we want to do here. What we can do instead is make a function just like this. I'm going to come down here and say function. And let's say is admin. Open the brackets. Now, when we call is admin, this function, we're actually going to pass in a parameter, just like we do in Swift. So I'm going to pass in a user ID, which I guess it is going to assume that it is a string. So in here, I can say if the user ID is equal to, and I can put this admin ID in here. We're getting an error because this function is unused. So now what I can do is I'm going to delete this. We're going to still use this request.auth.uid. We're going to say if they are authenticated and is admin. Now open the parentheses and paste in the user ID that it's looking for. So I will publish, and then hopefully I am the admin now. So we're back and we're working. Just to prove that it works, we can change this, publish, and not working again. Cool. All right. But again, this is not scalable. So what we can do is say, maybe here we create an array. We'll say let admin IDs, and we'll set it equal to an array where we have our strings. So we can have maybe my user ID. I can put in another user ID here, and I can do, again, just like in Swift, we can do a return if the user ID that we're passing into the function is contained in admin IDs. In admin IDs. So the syntax is a little different than Swift here, but it's definitely readable still as well. I think I need a semicolon here. Does that work? I think this works. Let's see, missing a semicolon at return. Oh, I need to add a semicolon at the end of this line as well. Cool. Publish. Let's make sure that it's working. Bang. And this is great, but guess what? We can make it even better. If this was the case, every time I want to change or add an admin, I'm going to have to come into my security rules and publish a new security rule. And generally speaking, these security rules, I want them to be pretty static. Like I personally don't really ever want to come into these rules and make changes because they're going to affect the live app. I want to write my rules, get them right, and not have to change them again. Not a big deal if I have to change them, but I'd rather not to. And secondly, if I had, 100 admin IDs, or maybe it wasn't is admin, maybe it was like, is special user or is part of our content team or our writing team. I'm not going to start coming into these security rules and manually copying and pasting all of their user IDs. If it was just me, I'm the only developer and I want to add an admin ID, I'll do this. It's quick, it's easy. But to scale this up, we actually want to instead have a reference in our database for all of these admin IDs. And so what we can do is actually, I'm going to copy this ID as an admin ID. I'm going to go to my database. I'm going to add a collection here and I'm going to call this admins. And then within the admins ID, I'm going to put the user ID as the document ID. And let's just put a field with the ID as well. And I'm going to put even a name here, just so on my end, when I look at the database, I know whose ID this is. So I'm going to say Nick's iPhone ID. Why not? And click save. And so if I had a whole bunch of people on my content team or my admin team, I would add in a bunch of documents here, one for each of their IDs, and I would add in their ID and maybe some info on who this is. This is for, I don't know, Charlie, and save. And so now my security rule, I just want to say they're an admin if their ID is found in the admins, if their ID is found in the admins collection. So we'll go back to our security rules. I'm going to comment this out. I'm going to comment this out. And what we're going to say instead is return if exists, meaning the document exists at a path. And so now we need to put in a path of where we are looking for a document that exists. And that path is going to be very similar to the actual path here, plus the admin collection. So I'm going to use a slash, and we're going to say databases slash, and this is a bracket, but in here we actually are going to put the $. It's a wildcard, and open and close parentheses, and put database. So any database. So this is, I think, referring to any database. So we're using this function right now within this database, and it works. But I think this would work if it was in like another database as well. And we're going to say slash documents slash admins. This is our admins collection that we just set up. And then we're going to say forward slash, and again, the $, open and close parentheses, and we're going to call this user ID. So user ID is that ID of the document ID here. And I believe we just need to put a semicolon at the end here, and I think it will work. So let's publish this, and I'm going to start doing some queries, and it's working. If I come here and I delete this user ID, I'm just going to copy it so I still have it. Let's delete the document, and let's write another one. And all of a sudden I'm broken because I'm not an admin anymore. Cool. So let's put this document back. ID. Awesome. So that was one way to scale up our function here. So now we're referencing a document in our database. So this is a pretty powerful way to handle your isAdmin function. And there's obviously more ways to scale from here, but I think this was a good intro of how to at least start to write your security rules. All right, a couple final things before we wrap up here. So right now in our app, our products are stagnant. So the products are not changing. And so what we want to write really is a rule. Let's just write some actual rules. So let's just say allow read. We're going to say anyone can read if they are not authenticated, if they are authenticated. And then we're going to say allow, let's break up the write here. So we're going to say allow create. We're going to allow, let's say authenticated admin can create documents. Let's say allow, what's the next one? Update. Authenticated admin can update documents. And let's say allow delete, and let's say if false. So nobody is allowed to delete documents, because in our app right now, we don't ever have a use case where we are deleting products. And so we can publish that. And so these rules are definitely better than having just the general anyone can read and write type rules. All right, one final thing that I want to touch on before we wrap up this video is that I'm going to try to hold this down and add this to favorites. And when I do that, we are not connected to Xcode, so I'm going to run it one more time. Let's see. All right, I'm going to build and run my app one more time, and this time I'm going to do the final thing in our app is basically our favorites array here. I'm going to add an iPhone 9 to it. Add to favorites, and we failed. Okay. And so in our code, we are allowing write if the user is public, which I believe we are public. Visibility is public, so we can write to the user document. And obviously we can read from the products. So why can't we write our favorite product? Well, that's because the write is actually not just going to the user document, but to the favorite products sub-collection of that user document. Remember, here we have the favorite products sub-collection. And so one thing that is important to note is that sub-collections do not inherit rules from their parent documents or collections. So what we actually need to do is write another set of rules in addition to the user document for the sub-collection of that user document. And so what I'm going to do is just copy this line of code here, allow match, and let's write that right in here. We're going to say match users, user ID. Within there is the, what do we call it? Favorite underscore products, favorite underscore product. And then within there is, we're going to open the brackets, and that will be the user favorite product ID. And that's referencing the document ID of these favorite products. All right, let's open the brackets. And who are we going to allow to read and write? So allow read, let's say any authenticated user can read from those. And for write, let's say maybe only the current user can write to their favorite products. So I think we wrote a rule for that already here. I actually want to put that same rule on our users. So let's actually uncomment this. Let's comment this out, comment it, copy it, and paste it here as well. Now only the user themselves can write to their own favorite products. Let's publish. Cool. And so now if I add the iPhone 9, it did not work. Did it work? I think maybe it did work, but it's not showing up here. Maybe we need to restart our app because the original fetch request failed because we didn't have the rules right the first time. But here it is adding now and it's working, right? So now we can also remove from favorites and we can add to favorites, and that's working perfect. Cool. So we wrote a lot of pretty good rules in this video. I'm just going to wrap up with, if you're interested in learning more, I highly recommend checking out this URL here, structuring cloud Firestore security rules. And then also check out this URL, which is the security rules language, where they talk about the different keywords that you can use. And I think they have some extra language. Yeah, so read, write, get list, create, update. And I think there's also a couple, so like request.method, we didn't use params, we didn't use path and resource. So there's definitely more security rules. There's a whole bunch of operators that we didn't touch on either that you can get into. I think the security rules that we talked about probably cover the vast majority of use cases. That's honestly all I've ever written, is basically the ones that we covered. But clearly there are some very specific ones if you really want to get into that. I will, if you are using the GitHub project that I have for this playlist, I will include both of these URLs in the project under a file here. I'm going to let's create a new group and call it security rules. Just going to move it down here. I'm just going to put a quick Swift file in here for you guys. That is just rules.swift, and it will have these two links. And let's put in let's see here. Let's just copy and paste all of these rules just so that we have them in our Xcode project so that you guys can see them. And I think that is it. Thank you guys for watching. Security rules definitely are a little annoying because they're not very fun to write, and they require us to take a little bit of extra time in setting up our database, but they are for us in the long run. They're going to save us in case anything goes wrong. They're going to keep our database secure so that only authenticated users can access our content. Only the correct users can read and write from the correct locations. So although it's a bit of a pain, I highly recommend at least setting up some basic ones before you go to production. All right, thank you guys for watching. As always, I am Nick. This is Swiftful Thinking, and I'll see you in the next video.